Welcome to Study Loop.
So first let's write down the known quantities to the problem. So we have theta to be 17.4 degree, mass is given to be 12.3 grams, and the charge is negative 1.11 microcoulombs. And we need to find the magnitude and direction of the electric field. Now, as shown in the figure, the ball is in equilibrium, which means that the vertical component of tension is in balance with the weight. So, the vertical component of tension is the magnitude of tension times cos theta, and that is in equilibrium or is in balance with the weight, which is mass times gravity. So, let's call this equation 1. Now the force due to electric field is in balance with the horizontal component of tension. So horizontal component of tension is T sine theta, and force due to electric field is the magnitude of the electric field times charge. And let's call this equation 2. Now let's divide uh, both these equations. So that gives mg over, let me just divide the respective sides. So t cos theta over t sin theta will be equal to mg over E capital Q. So this gives the electric field to be mg tan theta over the magnitude of charge, and the tension just cancels out because it's the same, it's common in both numerator and denominator. Now we can substitute all the values along with gravity, acceleration due to gravity, that is 9.8 meter per second square. And make sure you convert each of these units into standard units. For example, you need to convert grams into kgs and microcoulombs into coulombs. So 1 microcoulomb is 10 to the power minus 6 coulombs. So we need to multiply this factor over here, and you already know that 1 kg is 1000 grams. So 1 gram is 0.001 kgs. So yeah, just convert everything into the standard units and plug those over here, and that will give you the magnitude of electric field, and that comes out to be equal to 3.41 times 10 to the power 4 Newton per coulomb. Now, one more thing to uh, take care of is, as you see, your charge is given to be negative here. So when you multiply it with the electric field, just multiply the magnitude of the charge, which means that just multiply the positive part, the positive value, and that will just give us the magnitude of the electric field. Now, the time to consider this sign on the charge, and that will help us to find the direction of the electric field. Since the charge on the ball is negative, the force this force F has to be towards the right in order to cancel the component of T, cancel the horizontal component of T. This force F has to be towards right, which means that electric field has to be towards left, because the charge Q is negative. So we can say that there is a positive charge in somewhere in room, so the electric field lines is out of positive charge and is oriented to the negative, and as I said, for that reason the electric field has to be towards left. Now let me just explain this one more time. So the force, so this is the force, and this the magnitude of the force, and this force is towards the right in order to be opposite to the component of tension here. This means that the magnitude of the electric field, so in order to find the magnitude of force, we need to find both are the magnitudes only. So you don't need to put a mod sign around E because E itself is the magnitude and E itself is positive. So yeah, so since the direction of the force is towards right, and so F vector is towards right, and F vector is actually E vector times Q. So since Q is negative, this means that this force F to be towards right, E has to be towards left. So that negative and negative becomes positive. And therefore the direction of electric field should be towards to the left. That's it. I hope you get this part. And if not, please comment down below.